Alright, part 3, gas metal arc welding, gas metal MIG welding. General, gas metal arc welding and electrical arc welding process with the joined metal by heating with an arc with established with a continuously filler metal with consumable electrode to the work. Shield the arc and the molten weld pool is obtained entirely with external supply with a gas mixture with the shown figure 1044. The process sometimes referred to as MIG or CO2 welding. The recent developments process included operation of low current density pulse direct current, the application of the broad range of the material, the use of the reactive gases, particularly with CO2 and gaseous mixtures. Later development has been led to formal acceptance of the term gas metal arc welding for the process because of the both in air and reactive gases are used. The term the MIG welding is still more commonly used. The MIG welding is operating in semi-automatic machine with automatic modes and usually, particularly with a high production welding operation, all commercial and important metal with the carbon steel, with the stainless steel, aluminum, copper can be welded with the process in all positions, choosing with appropriate shield of the gas and electrode welding conditions. Figure 1044 shows the gas metal arc welding process. The base metal arc consumable electrode direction of travel, the shielding gas and shielding a solid electrode wire with current contact, conductor wire, guide, contact tube, gas nails, gas shielding welded metal. The equipment. Gas metal arc welding equipment consists of the welding gun and power supply with a shielding gas supply with a wire-driven system with which pull the wire electrode from the spool that pushes it through the welding gun. A source of cooling water may be required for the welding gun. With the passing of the gun, the wire becomes energized by the contact with the copper contact with the transfer of the current with the power of the source of the arc, which is simple in principle and is given the system accurately controls the inflow with the initiate with the terminate with the shield of the gap with the cooling water operate with the welding contact with the control feed. Speed is required. The basic feature for the MIG welding equipment is shown figure 1045 of the MIG process is used with the semi-automatic machine and automatic welding. Semi-automatic MIG welding is also often referred to as a manual weld. When driven by may be located in welding gun or wire reel, shield gas DC welder, contactor, wire read, wire drive, wire reel, controls governing the wire drive with the constant current with the gas flow with the current water cooling water if used, and gas is supplied. There are two types of power source used with the MIG welding, the constant current and the constant voltage. With the constant current power supply with the type of the welding current with the established with the appropriate setting of the power supply with the arc length with the voltage axe controlled with its automatic adjustment of the electrode feed rate. This type of the welding is best suited with the large diameter electrode of the machine. The automatic welding, while very rapid change with electrode feed rate does not require more constant power with the source that has the dropping voltage ampere output characteristics. However, the true constant current power machines are available. Constant current power sources are not normally selected for the MIG welding because of the control need for the electrode with the feed speed, but the systems are not self-regulating. Constant voltage power supply arc voltage is established by setting up output voltage of the power supply with the power source will supply with the necessary amperage to melt the welding electrode at the rate required for the maintaining the present voltage of the relatively arc length, speed of the electric drive, the U of the control of the arc welding current with the characteristics generally preferred to the welding of all metals. Usually the type of the power supply with the conjunction with the constant wire feed speed results in self-correcting arc length. Motor generator with the DC rectifier power supply sources with either type may be used with the whole directed current power supply with the power source pulse over the DC output with the low background value, the high peak value with the peak of the average power with lower pulse pulse welding current can be used in welding thinner sections than those of the particular practical state of the DC spray transfer. Welding guns. Welding guns that make welding are available with manual manipulation, semi-automatic with a machine with the automatic welding because of the electrode fed. With this constantly welded, the gun must have the sliding electrical contact transmit with the welding current to the electrode of the gun. Also has the gas passage of the nozzle directly to the shielding around with the arc of the molten welded pool. Cooling is required to remove the heat generated within the gun radiated with the welded arc with the molten welded pool with the shielded gas internal radiated with the welding arc with the molten welded metal shielded gas internal. Circulating water, both are used for the cooling and electrical switches needed for the start and stop of the welding current with the electrical feed system and then shield with the gas flow. Semi-automatic guns and automatic with the handheld guns are usually similar with the pistol in shape, sometimes shaped similar with the oxyacetylene torch with the electrode with the wire feed with the barrel with or a handle. In some version of the piston is a pistol designed where the most cooling is necessary with the wires directed through the nozzle with the passage of the cooling bolt with the contact tip with the metal shield the gas nozzle, the curved gun over the curved current carrying body at the front of the end through the with the shielding is brought with the nozzle with the type of the gun is designed for the small diameter wire with the flexible maneuverability. It is suited for welding in tight, hard for each corner of the other confined space. The place for the gun is equipped with the metal nozzle with the various internal diameters to ensure the adequate gas shielding. The orifice usually varies with approximately 3/8 of an inch to 7/8 of an inch depending on the upon welding requirement of the nozzle usually threaded to make the replacement. Easier the conventional pistol pipe holder is also used with the arc spot welding application with the filler metal is required with a heavy nozzle with a hole that slide with exhaust gas away from the spot with the pistol grip handle pennants. Easily manual loaded with a holder against the work with the welding control with the designated with the regulated with the flowing with the cooling water supply with the shielding gas. It also is designed to prevent wire-free freezing with the welding, timing of the welding over a preset interval with a typical semi-automatic gas-cooled gun is shown in Figure 1046. The E1046 shows the typical semi-automatic gas-cooled curved neck weld gas metal arc welding gun, welding current contact nozzle, gun switch, gas tube, composite cable, gun handle, and electric guide tube. Your air-cooled guns are available in the application where the water is not readily obtainable. The air cooling medium of the guns are available to serve the up to 600 amps intermittent duty with the carbon dioxide shield. The gas, however, they are usually limited with the 200 amps argon helium as shielding. However, is generally pistol-like and operating similar with the water-cooled. These general type of the air-cooled guns are available. One, a gun that has electric wire feed through the flexible conduity with the remote wire feeding mechanism. The conduity is generally 12 foot with the length of the ranging through with the wire feeding limitations of the push-type system. Steel wires of 7/20th to 5/16th of an inch diameter. Aluminum wire with a 3/64th to 1/8 of an inch diameter can be fed with this arrangement. A gun with a self-contained wire feed mechanism. Electric wire supply with the wire supply is generally in the form of the 4-inch diameter, 1 to 2.5 pound spool. The type of the guns employed with the pull type of the wire feed system, not limited to by a 12-foot flexible conduity. Wire diagrams from 3/10 to 5/32 for the inch are normally used with this type of the gun. A pull type gun that has electric wire feed with the flexible conduity with a remote spool with the incorporated with the self-contained wire feeding mechanisms that also be used with the push-pull type feeding system. The system permits the use of flexible conduity for the lengths up to 50 feet or for more than from the remote wire feeder. Aluminum steel electrode with the diameters of 3/10 to 5/8 of an inch can be used with these type of feed mechanisms. Your water-cooled guns remain with the MIG welding, similar to the gas-cooled type with water, as addition with the water cooling done with the duct, circulate with the water around with the contact tube with the gas now with the water cooling permitted for the gun to operate continuously with rated capacity and lower temperature with the water-cooled guns are used with the application requiring 200 to 750 amps. Water and outlet lines of the gun, added weight with the reduced maneuverability of the gun for welding. Then the selection of air and water-cooled guns is based on the type of the shielding gas, welding current range, materials, weld joint design, existing shop practice. Air-cooled guns are heavier than water-cooled guns with the same welding current capacity. However, the air-cooled guns are easier to manipulate, weld out of position in confined areas. The more advantage of the gas metal arc welding is that high quality welding can be produced much faster than steel metal arc welding and TIG welding. Since the lead flux is not even, there's no chance of the entrapment of slag in the weld metal. The gas shield protects the arc so that there is very little loss for the alloy elements of the metal transfer across the arc. Only a minor weld spatter is produced or easily removed. Process for versatility can be used with a wide variety of metals alloys, including aluminum, copper, magnesium, nickel, and many of the aluminum as well as the iron and most of the alloys. The process can be operated in several ways, including semi and fully automatic MIG welding is widely used with many of the industries welding broad variety of materials and parts within structures. The major disadvantage of this process cannot be used in the vertical overhead welding positions due to the high heat of the input and the fluidity of the welded puddle. The equipment of the complex compared with the equipment used for the shielded metal arc welding process and process principles. Arc power, the vast majority of the MIG welding application require the use of the direct current reverse polarity electrode positive with the type of the electrode connecting action yields of the stable arc with the shield and smooth the metal transfer the relatively low spatter loss. Good weld bead characteristic of the entire range of the welded currents. Direct current straight polarity with the electrode negative is seldom used with the ascent of the arc. And become unstable erratic even with the electrode melting of the rate is higher than achieved with the drop of the direct current reverse polarity electrode positive. When employed with a direct current straight polarity electrode negative with the conjunction with the buried arc with a short circuiting metal circle the penetration lower than the straight polarity with the reverse polarity of the direct current. Alternating current has found no commercial acceptance for the MIG with the welding process for the two reasons. The arc is extinguished during each half cycle as the current reduces to zero. It may not reignite with the cathode cool sufficiently to reactivate rectification of reverse polarity cycle promotes erratic arc operation. Alright, your metal transfer. The filler metal can be transferred with the electrode working into the two ways of the electrode contact with the molten metal pool, thereby establishing short circuit, which is known with a short transfer circuit with a short circuit arc welding. Weld is discrete with the drop of the arc move with the crop of the arc gap of the influence of the gravity of the electromagnetic. First, the drop transfer can be either globally or spray type of the shape of the side of the direction with the drop of the axle, non-axle, the type of the transfer with the determined with the number of the factors. The factors for the most influences are magnitude, the type of the welding current density, electrode composition, electrode extension, shielding gas, and power supply characteristics. Axially directed the transfer refers to the movement of the drops along the line with the continuation of the longitudinal axis of the electrode. Non-axial directed transfer refers to movement in any other direction. Your short circuit transfer, the circuit arc welding, usually the long range of the welding current electrode diameters associated with the MIG, with the type of the transfer, the produce of the small and free for us welding pool over the generally suited with the joining of these thin section out of position welding, filling a large root openings will welded heat input with extremely low plate distortion. And small metal is transferred from the electrode to the work only during the period of the electrode is in contact with the welded pool. There's no metal transfer across an arc gap. The electrode contact with the molten weld of the pool at a steady rate with a range of 20 to 200 times each second. The wire touch with the welded metal with the current increase with the weld continue with the increase with if the arc did not form. The rate of the current increase with the most high enough to maintain the molten electrode tip of the filler metal with the strain for the short. It should not occur with the so fast that it could cause a spatter by the disintegration of the transferring drop of the filler metal of the rate of the current increase of the control of the adjustment of the inducing the power source of the variety of the inductance required. It depends on the voltage of the electrical resistance of the welded circuit and temperature range with the electrode melting. The open circuit voltage of the power source must be long enough to end the arc continuing under the existing welding condition. The portion of the energy of the arc maintenance is provided with the inductive storage of the energy during the period of short circuiting. As metal transfer the only with the current with the during the short circuit and shield the gas have very little effect on the type of the transfer spatter can occur. It usually caused by either gas evolution or electromagnetic forces on the molten tip of the electrode. Your globular transfer with the positive electrode with the direct current reverse polarity. Globular transfer takes place when the current density is relatively low regardless of the type of the shielding gas. However, the carbon dioxide shield yields the type of the transfer of all usable welding currents. The globular transfer is characterized with the drop side with greater than diameter than the electrode. Globular axial directed transfer can be achieved with a substantially inert gas shield without spatter. The arc length must be long enough to ensure detachment of the drop before contact with the molten metal. However, the resulting weld is likely to be unacceptable because of the lack of the use and efficient penetration with excessive reinforcement. Carbon dioxide shielding always yield the non-axial directed globular transfer due to the electromagnetic repulse of the force acting on the bottom of the molten drop of the forcing electrode current from the electrode generated with the surface force of the act upon the molten tip of the most important of the arc pinch for the force and anode react on an ion force of the magnitude of the pinch force of the directed function of the welding current with a wire diameter usually responsive for the drop of the detachment within CO2 shielding. The wired electrode is melted with the arc heat of the conductive with the molten through a molten drop. The electrode tip is not enveloped by an arc plasma, and the molten drop grows until it detaches from the short circuiting or gravity. Your spray transfer. In gas shield with at least 80% of the argon or helium filler metal with the transfer change with the globular to spray type of the welding current increases for the given side of the electrode from all metal to the chain with the take of the plate with the current value from a globular to spray transition current. The spray transfer has a typical fine arc column with the pointed wire type associated with the molten filler metal with the transfer of the crop of the arc with a fine drop of the metal with the droplet diameter that's equal to the less of the electrode diameter. Molten metal spray with the axial directed with the reduction with the droplet side, but is accompanied by an increase of the rate with the droplet detachment. Illustrated in Figure 1047 of the metal transfer rate may range from less than 100 to several hundred droplets per second as the electrode feed rates increase with approximately 100 to 800 inches per minute. Show the 1047 show the variation volume of the transfer rate with the rate drops of the welding current. Your free flight transfer. The free flight transfer liquid drops from form of the tip of the consumable electrode arc. A consumable electrode are detached and travel freely across the space between the electrode and the workpiece before plunging into the weld pool. Before transferring the gravitational of the drop, the detail of the gravitational alone falls slowly through an arc column that projects the type of the transfer. The other force of the driven given with the drop, the initial and acceleration projection, and independently with gravity to over the welded pool. During repelled transfer, the force acts upon the liquid drop of the given initial with the velocity of the direction directly away from the welded pool with the gravitational projection type. Ties of free flight metal transfer may occur with the gas metal arc welding of steel, nickel alloys, aluminum alloys used with the direct current, electropositive, reverse polarity arc, and properly seated elected types of shielding gas. Alright, at low currents of the wire with these alloys of the metal slowly, the large cylindrical drop that form with the tip of the detach with the force due to the gravity exceed the surface tension of the cursor in current increase with the electromagnetic force becomes the significance of the total separation force increase with the rate of the which of the drop of the form of the detach also increase as a certain current of the chain of the curve of the character of the arc of the metal train for the arc of the column of the previously bell shape of the cylindrical with the having relative with the lower brightness becomes the narrow and the more cylindrical and has the brighter central core. The droplets of that form from the wire tip become elongated due to the magnetic process and are detached with a more higher rate. When the carbon dioxide is used as a shielding gas, the type of the metal train for is much different. The low, medium, and reverse polarity term of the drop appears to be repelled from the work electrode and eventually detached from moving away from the working piece from the welded pool. This causes an excessive amount of the spare that the high current for the transfer to less of the irregular because of the force of the primary electrical overcome and the repelling forces. Direct current reverse polarity with the recommended with the MIG with the welding process with the straight polarity with the alternating current that can be used by requiring precaution with a special coating with electrode wire, especially with a special shielding gas mixture. Filler wire path with the copper contact tube with the gun where the pickups of the welding current. Some of the main welding guns contain with the wire driven the mechanism with the gun itself. Other guns require with the wire feeding machine with the mechanism with the be located with the spool of the wire with which is some of the distance from the gun. In this case, the wire is driven through the flexible conduit of the welding gun. Another manual gun design combines feed mechanism with the gun and wire supply itself. The argon and shielded gas with the most often with small amounts of the oxygen, 2 to 5% of the frequently are added to the shielding gas. When steel is welded, this stabilizes the arc of the permanent for the better wetting action, producing a more uniform welded bead, reducing undercut. Carbon dioxide also used as a shielding gas because of the cheaper than argon and argon oxygen mixtures. Electrodes designed to be used in carbon dioxide shielded gas require extra deoxidation formulation because of the heat of the arc of the carbon dioxide dissociates to carbon monoxide oxygen, which causes the oxidation of the welded metal. Welding parameters figure 1048 through 1054 show the relationship between the voltage and the current level, the type of the transfer, and the arc of the cross. 1048 shows the voltage versus the E70S2 1/16 of an inch diameter electrode shield the gas argon with 2% oxygen addition, spray transfer region for global transfer region. Voltage versus current of the E70S2 E70S2 1/16 of an inch diameter electrode carbon dioxide shield gas repelled transfer region, projected transfer region, short circuit transfer region, voltage and current in amps. 1050 shows voltage current with the E73 1/16 of the diameter electrode shielding gas argon with 2% oxygen, unstable short circuit region, this global transfer region, spray transfer region, and volt and current in amps. Your voltage versus current with the E73 S3 1/16 of the diameter electrode carbon dioxide shield of the gas repelled transfer region, short circuited region, projected transfer region. Voltage versus current with the E74 with the 1/16 of the diameter electrode carbon dioxide shield and gas repelled transfer region, the short circuited transfer region, projected transfer in the region, volts and amperes. Voltage versus currents with the E76 of the 1/16 of the inch diameter electrode carbon dioxide shield with the voltage of the short circuited transfer region, projected transfer region, repelled transfer region. D54 with the voltage versus the current with the E110S 1/16 of the diameter electrode shielding gas argon with 2% oxygen, global transfer region, spray transmission voltage and current in amps. Alright, your welding procedure for the welding process for the MIG are similar to those of the arc with the welding process for the adequate with the fixture for the clamp of the work or required with the adequate accessibility with the welding gun with the fixture must hold for the work with the rigid of the minimum of the distortion from the welding should be designed with the easy loading of the unloading of the good connection for the work lead of the work piece for the fixture is required. Location of the connection is important, particularly with the welding of the ferrometric materials such as steel with the best current direction of the welding is away from the work lead connection of the position of the electrode with respect to the welding joint. It's important that in order to obtain the desired joint penetration, the fusion, weld bead geometry, electrical position with automatic MIG welding are similar to those of the submerged arc welding. When complete with the joint preparation required with some method of the welded backing will help the control of the back strip of the back welding. Copper backing bar can be used with the back strip of the back weldings usually are left in place. Copper backing bars are removable. Assemble the welding equipment should be done according with the manufacturer's directions. All gas and water connections should be tight with it. There should be no leaks. The air separation with the water air with the shielding gas will result in the erratic operation. Arc operation and contamination of the weld porosity are porosity may also occur. Alright, the gun nozzle side of the shielding gas flow rate should be set according with the recommended with the welding procedure with the material with the joint design of the as with the weld the joint design with the required with the longer nozzle the work distance will need higher the gas flow rates than you with the nozzle normal nozzle the work distance of the gas nozzle should be adequate side of the provide good gas coverage of the welded area when the welding is done. Confine the area with the mirror and root thick welded joints. Small size nozzles are used. The gun contact tube with electrode feed drive rollers are selected with a particular electrode composition diameter specified with the equipment manufacturer of the contact tube with the wheel wear. The usage and most replaceably periodically good electrical contact with electrode is being maintained. Heating with the gun is to be minimized. Electrode extension is set with the distance between the tip of the contact tube of the gas nozzle. Opening with the extension of the U with the relay with the type of the MIG with the welding. Short circuit with the spray train transfer. It is important to keep the electrode extension of the nozzle the work distance the uniform as possible during the welding. Therefore, depending on the application of the contact tube, may be inside of the flush with extend beyond the gas nozzle. The electrode feed rate with the welding voltages are set to recommend the value of the electrode side of the material with the constant voltage power. So, with the welding current will establish the electrode feed rate with the trial bead with the will shall be made with the established proper voltage arc length with the feed rate values. Other variable the slope of the control of the inductancy both ends should be adjusted with a good arc starting of the smooth arc operation minimum spare optimum settings depending on the equipment design with the control of the electrode material with the side of the shielding of the welded joint design base metal with the composition thickness and the welding position welding speed. All right, your flex core arc welding. We'll just cut the tape so it's a shorter one.